Now, question 3.3, this is what we have. A ball is dropped from a height of 24 meters. Okay, so we have a ball being dropped from 24 meters. Every time the ball hits the ground, it rises 3/4 of its original height. So 3/4 of its original height, which of course is going to be this 24 meters. Okay, calculate the sum of the total vertical heights reached by the ball after the first bounce. So after the first bounce until it comes to rest. Okay, so let's understand this question. And I'm just going to use a drawing to really just break it down. So we have this ball, right? And this ball is being dropped from a height of 24 meters. Now, every time the ball hits the ground, so it eventually hits the ground, right? Every time it hits the ground, they say that it rises 3/4 of its original height. Okay, we have to really think about that. If it hits the ground, it rises 3/4 of whatever its original height was, which is the 24. Now, with the way this is being phrased, I don't think they meant of the original height. This is the reason I'm saying so. They said every time it hits the ground, it's going to rise 3/4 of its original height. If it did that, this is what's going to happen. It gets dropped 24 meters, it hits the ground, then it rises 3/4 of its original height. It hits the ground. Then it rises again 3/4 of its original height. Then it hits the ground. That's the reason why I'm saying I don't think they meant original height. I think this word should have been previous, because they say that it's going to keep doing this until it comes to rest. Well, if this ball is going to hit the ground and then rise 3/4 of its original height every single time, then this ball is never going to come to a rest. It's just going to keep reaching the exact same height, 3/4 of its original height, 3/4 of its original height every time. And that's not possible. So that's why I'm saying I think this should be previous height, because it comes to rest at some point. So for it to come to rest, for it to eventually just stay on the ground, what it should be doing is it is reaching 3/4 of its previous height, meaning it gets dropped. This is the original height, right? Then it hits the ground and then it rises 3/4 of whatever the previous height was. Then it hits the ground again and then it's going to rise 3/4 of whatever the previous height is. This height is 3/4 times 24. So it's going to be 3/4 of this height now. This 3/4 times 24. And if I want to clean this up and just write it in the correct way, and let me just even show you, for example, the third bounce, right? The third bounce would be lower again. So it's going to hit the ground, then it will rise 3/4 of whatever this height was, not original, but the previous height. So it's going to be 3/4 of everything here again. Okay, so 3/4 of all of that. So if you clean this up, this is actually what this is saying. First, the ball drops from a height of 24, then it bounces and hits this. Now, because I can see that 3/4 is a ratio that keeps being multiplied here, this is how I can rewrite this. Instead of writing it like this, I can just say 24 multiplied by 3/4. So it's just multiplied by 3/4. Then this one, I can say 24 multiplied by, do you notice that there are two 3/4s? Brackets just mean to multiply. So just multiplying all these numbers throughout. So I could just say 3/4, because there's two of it, squared. Then the next one would have been 24 times 3/4 to the power of 3, and so on. Okay, but let's just make sure that we're actually answering the question they're asking for. The question is, calculate the sum of the total vertical heights reached by the ball after the first bounce until it comes to rest. So after the first bounce. So think about it. This is not a bounce. This height of 24. This is just the height that the ball was dropped from. This is the first bounce. So this is where our pattern starts. Our pattern starts at this height, right? That 24 times 3 over 4. That's our first height, height 1. And then this would be our second height that the ball reaches. This is the third height that the ball reaches. So clearly you see we have to start from here. That's the first term, not this 24, because they say after the first bounce. That is the sum of the total vertical heights we must calculate. So this clearly creates a series. And if you think about it, this series, we are only calculating the height that the ball reaches, but this series is going to converge. And this is why I'm saying it's going to converge. A series that converges, it really just means that the pattern is heading towards a specific number. And this is why I'm saying this. You see that the heights of these, they're getting smaller. Because 3 over 4 is a proper fraction. The numerator is smaller than the denominator. So every time you multiply this by 3 over 4, it gets smaller. So this is going to keep on getting smaller throughout. So it's going to keep getting smaller and then smaller and smaller and smaller. Now think about what's the smallest height, or what is the only height that this ball cannot reach, okay, or cannot go beyond. That height would be 0. Because when this ball reaches a height of 0, it's not even in the air anymore. It's now on the ground, okay? So the height that it will not go beyond, right, would be 0. So it's going to keep on bouncing. That's why when you watch a ball bounce, it just bounces, bounce. And you don't even know how many times it bounced until it stopped bouncing and it was just on the floor. So this is going to be, it's a geometric series. It's a geometric series that converges. These heights are heading towards a specific number. It's heading towards 0. Okay, so that's the sum of all the heights. So let's go ahead and write the pattern. The pattern is really the first term that we have is 24 times 3 over 4. Okay, that is our first height, because clearly they tell us the sum of the total vertical height reached after the first bounce. There's the first bounce, then it goes up. That's the first height, okay? So after the first bounce. Then, of course, the second one would be that 24 times 3 over 4 squared, then 24 times 3 over 4 to the power of 3. And this will keep going, and it's going to be heading towards 0. Getting closer and closer to 0. It will not go beyond 0. So, to calculate the sum of all these heights, because it's a converging geometric series, we have to use sum to infinity. And the sum to infinity formula is a over 1 minus r. And this is what we have. So sum to infinity, what is our a value? It's this, 24 times 3 over 4, and then over 1 minus, what's our ratio? So the ratio you can just find by saying this, term 2 divided by term 1. You see, if you say term 2 divided by term 1, look what's just going to happen. You're just going to have 24 cancel, and then 3 over 4 will also cancel. One of it cancels here, and that cancels. So do you see that the ratio is just 3 over 4? So 3 over 4. And then we can just put this onto a calculator and then get our answer. So let me go ahead and put it on. And our answer is 72. But remember, these are heights. So let's just go ahead and see exactly it's in meters, right? Because it was dropped from 24 meters. So the answer is 72 meters. And that is the answer for 3.3.